In this video, I will teach you how to predict equilibrium position of acid-base reactions using pKa values. And the most important thing that we need to remember is that equilibrium always favors the side with the weaker acid. So in order for us to do this correctly, first thing we need to do is identify base and acid on the reactant side and the conjugate acid and the conjugate base on the product side. The definition of Bronsted Lowry acid is that it is a proton donor or H plus donor. So an acid will lose a hydrogen. A base is a proton acceptor. A base will accept or gain a hydrogen. So let's go ahead and look, going from the reactants from the left side to the right side, what happened here. I see here that I have a hydrogen here on the left side and it is missing on the right side. That means this molecule lost a hydrogen, and that means this must be my acid. And on the other side, this must be its conjugate base. And let's do the same for this molecule. OH minus becomes H2O. OH minus gains a hydrogen. That means this was a base. And on the other side, this will be its conjugate acid. Now that I have identified the two acids, next, I need to figure out which is the weaker acid, and for this, I can use my pKa chart. Let's go ahead and find this kind of molecule, which is called carboxylic acid, in my pKa chart. So if we look here, it says that its pKa is 4.74, so let's write that here. And the next acid is water. What is the pKa of water? It's 15.7. pKa tells you how acidic something is. The lower the pKa, so the smaller the pKa value, the more acidic your molecule is, the stronger of an acid it is. That's why in my chart you can see that HI has a very, very tiny pKa value. It's actually negative and it's the strongest acid. And then an alkane, such as ethane, has pKa value of 50. It's a much bigger pKa value. So the key is to remember that the smaller the pKa value is, the stronger the acid is. And we also have to remember that the equilibrium always favors the side with the weaker acid. Now that I have identified my pKa values for the two acids given, I am going to figure out which one is the weaker one. And we said that the lower the pKa, the stronger the acid, and that means the higher the pKa, the weaker the acid is. That means water is the weaker acid out of the two because it has a higher pKa. And that means that for this reaction, equilibrium will favor the product side, the right side, which is the product side.